So let's try and solve the 2013 question 1 item 4. Okay, now the question is telling you that in the first situation you have in this cylinder here a gas and the pressure is P0 and this is the volume. After you heat it, the pressure will still be constant. You won't change the pressure, but the volume will change. You will increase the volume. Okay, so I'll give you 3 tips to try to solve it by yourself, and then we're going to solve it together. Okay, so remember that pressure versus the volume is equal to material N versus this constant R versus T. Okay, you won't need to worry about this concept. The second one is, he said that in the question he said that it is a monoatomic gas. So for this type of gas you will have the formula for the internal energy, and I will tell you why you will need internal energy. Okay, but the formula is 3 divided by 2 nRT. Okay, and as we don't have the pressure is constant, so we can use that the work done by the system is the pressure versus the variation of the volume. Okay, now, like, why do we need to think about the internal energy? Well, you added up heat in the system, but you didn't change the pressure, right? You did change the volume, but like, look at this situation. I hope you tried to solve it alone, because now I'm going to start solving it. Okay, so you will have the pressure in situation 1, which is over here. This is situation 1 and this is situation 2. Pressure in situation 1 versus pressure in situation 2 versus volume in situation 2. And now I'm just going to take this this temperature and put it dividing over here. Temperature 1 is equal to N versus R. Okay, pressure versus situation 2, volume 2, temperature 2 is equal to NR. Now you don't lose any of the gas. All the material of the gas is still in here. It just expands, but you don't it doesn't go out of the box. So the N versus R is a constant. Okay, this doesn't happen always. Okay, if he tells you that you lose the material, you need to add that to the account. But in this situation you have that PV1 divided by T1 is equal to NR, but NR is equal to pressure 2 volume 2 divided by T2. And this is the thing, he tells you that the pressure is constant, so pressure 1 and pressure 2 is equal, so we can cut it, and the volume divided by T1 must be the volume divided by T2. Okay, so this is what we're going to use now. What do we need to like observe over here is that our volume in situation 2, the volume increased, right? So if the volume increased, what does the temperature 2 needs to do so that we can this equality can stand? So if you had like 3 divided by 2 is equal to 3 divided by 2, if this one increased to like 3 to, let's say, 6, the 2 must increase together, right? Because you need the equality to maintain. So if the volume 2 increased, the temperature 2 increased to increase together. So you increase the internal energy. Okay, and this is what we need to put in account. And the work, well, you have a variation of volume. Whenever you have a variation of volume, you have a work done. And this is the fourth tip, so we will have that fourth tip, okay? That the heat you add to the system is the internal energy plus the work. Okay, so if you didn't solve it in here after what I said, try to solve it now. Like, put these equations over here and this equation over here, and in place of the nRT, try using this one, the first equation, okay? So try to solve it. Now let me solve. So and remember, the question wants this key over here. This key represents the heat that you add on the system, okay? So the internal energy, remember, it's 3 divided by 2 nRT plus the work. The work is pressure versus the variation of the volume, okay? But remember, what is this one? nRT. It is the pressure versus the volume, okay? The variation of the internal energy is the nRT, the variation of temperature, okay? So we'll have the variation of volume over here. Can you understand what I'm saying? Like, this part over here, you will change it with this part over here, okay? So the heat, what the question wants, it's P, the variation of volume, plus P, the variation of volume, okay? And now we know that what is the variation of volume? The final volume minus the initial volume, right? So 3 volume minus the initial volume, right? This is the volume initial and this is the final, okay? So we can do this part over here. So 2V, right? This is the variation of volume. 3 divided by 2 minus V, like it is V. No. No. Yeah. Yes, this. Okay. And we will use this, what we just found, over here. V divided by 2. Okay. So the heat is equal to 3 divided by 2 pressure versus V divided by 2 plus P. Remember, this one is V divided by 2. So T is equal to 3 divided by 2 versus 2. 2 versus 2 is 4 PV plus PV divided by 2. So 4, 2. So the 5 divided PV. Oh yeah, kiddo. So we'll have that the answer is letter H, okay, on the question. So just remember, kiddo. So look, going back, reviewing. So we know that he wants the heat, and we know that the heat is equal to the internal energy plus the work on the system. So we know that this was the first situation we had, and then we increased the volume. How? By putting heat on the system, increasing the internal energy, and part of the heat that we added released work on the system, okay? So remember that the formula for the internal energy is this one, and that you can take the nRT with this one, okay? so putting PV over here, and then all this part over here was just to explain the situation that we increased the volume, so the temperature increased, and then we just put the values of the equation of these two, this equation, using number 2 and 3. Okay, and then we found this part over here, and the answer is H. Okay.